We're gonna start with a lead code exercise from the area of probability and statistics. We're gonna start with this question, the 470 implement random 10 using Rand7. So here we go to the exercise, and basically it says given the API Rand7 to generate a uniform random integer in the range of from 1 to 7 strictly, means like it doesn't include the 0, includes the 7. Write a function Rand10 that generates a uniform random integer in the range from 1 to 10. You can only call the API Rand7, and you shouldn't call any other API. Please do not use a language built-in random API. Each test case will have one internal argument and a number of times your implemented function Rand10 will be callable test. Know that this is not an argument past Rand10. So basically what it says is this function Rand10 does not have any argument, meaning like the time that this is going to be called is going to be all like a standard for loop when the function from the API basically we're creating here will be called. So it won't have like the end in the argument. Rather, the function we call, for example, one time, which generates one number in between 1 and 10, which will be 2, or in this case, two numbers would be 2 and 8, or two elements would be 3, 8, and 10. So basically, we only can use the function, the built-in function, Rand7, and it generates numbers from 1 to 7 that is already provided. And we have to implement this function to generate random numbers from 1 to 10 without using an external API. There's not any other like from the random, and basically that's it. And the constraints is like the n is in between these numbers. Also follow-up questions or follow-up aspects. What is the expected value for the number of calls to Rand7 function? And also could you minimize the number of calls to Rand7? So basically here I'm gonna use this whiteboard first, and okay, so basically here we have to call the function that is the Rand7, that is basically, if we call it once, we want to look to minimize the space complexity and runtime complexity. So basically we need to call it at least once and know that 7 is less than 10. So of course we'll have to call it more than once. If we call it twice, we're gonna generate first outcomes from the probability from 1 to 7. And if we call it again, we're gonna have the outcomes from 1 to 7 again in 2 calls. Basically, these are the outcomes. So as this can produce like 7 possible outcomes, and this can produce 7 possible outcomes, if we multiply both events, as these are like independent events, this is event 1 and this would be event 2 that are independent from each one. So here we have 7 outcomes. We will have a total of 49 possible outcomes. So we can see these as rows and columns, basically, is what we can see here. So having said this, basically we can see it as a grid of a matrix of 2 possible outcomes. That is the minimum that we'll still have to call the API. As if we have like 49 possible, we surely be able to generate numbers that includes the range from 1 to 10 from the 49 possible outcomes. Here, but we will have it's like rows that range from 1 to 7 and columns that range from 1 to 7. So here having like a grid, here we will have like rows that range from these, columns that range from 1 to 7, and 1 to 7 also 4 rows. So we can traverse any of these possible outcomes, in which case we will have basically For example, here 1, 2, 3, etc., ranging on up to 49. There is a way to linearize basically the accesses to the matrix. Basically, we have like an array that is from I rows, j columns. We can linearize this. Doing the accesses will be the position I multiplied by the number of columns plus the j-axis that is for the columns. If we see this as basically the accesses of the outcomes of the generating numbers in the API, so basically here we will have one call from Rand7. This will give numbers from 1 to 7. If we subtract 1 to like use the same formulation from ranges that start from 0 to linearize the accesses, so here we will have elements that now will be from the range from 0 to 6, being 7 elements. We basically then multiply these by the number of columns that are 7 and sum these by the outcomes in the columns. That will be Rand of 7 minus 1, and this will give us the possible outcomes, 49 possible outcomes. Now, as we need two accesses that give 49 accesses, and the bigger number that is like a multiple of 10, it's 40. So basically, we will be trying over all the 49 possible outcomes, and only 40 will be valid. The rest will be discarded and try again, basically. This will be the approach to solve this exercise. And basically, as 40 is like divisible by 10, so basically here we will have basically starting from, so as this is an axis that starts from 0 to 6, this starts from 0 to 6 and so on, so this is going to be ranging from 0 to 48. So this can generate 7 possible outcomes, and this is going to give us the total of like the range of numbers that we can generate. Or we started from 0, subtracted 1 by one of the functions, each of the functions. So here, if the number is less than 40, basically from the range of this, if we divide this by 10, basically dividing this by 10, it will be having 4 even splits. As we have 4 even splits, if the number is less than 40, let's say like 39, for example, and we do the model of 10, we're going to have 9. So we sum 1, and now we will have 10. If we do 48 module of 10 plus 1, we will have 9. The interesting thing is, like if we had, for example, 28 module of 10 plus 1, we will have 9 as well. So basically we will be generating numbers from 1 to 10 in 40 of the 49, 40 out of the 49 possible cases, meaning like we're gonna discard 9 cases. If it's one of the 9 cases, basically the probability of getting a number that is multiple of 10 that we can like use using this logic is basically this probability, which is higher than it being a number that is out of this range, basically. We can prove this, for example, by this example that I have here in Python. Basically, we have like the module of 10 plus 1, it will be 10. It gets circular, as basically it's dividing the range of numbers evenly split in 4. So here we're gonna go to the solution of this exercise. Basically, here we're gonna do a while loop that we are going to constantly be checking for the possible outcomes of the calls for the Rand7 function. Here we will have a variable representing the row that comes from the Rand7 function that is already provided to us. We're going to have a variable for the columns in this array, which the multiplication of row multiply column will be 49 possible outcomes. And the logic to access in a linearized way to access the outcomes from the numbers will be the row subtracting one element to start using 0 multiplied by the number of columns shown by the accesses in the columns starting from 0. This will be range of 0 to 48. So here in this while loop is basically the number is less than 40. That is one of the cases in which case can evenly split the array. We are going to leave the function returning the number. So basically here we're just doing mapping the number to the range 1. Instead of doing like the logic that we explained in the whiteboard. So we're going to calculate the module of a number that is in the range of 0 to 39, there are 4 elements. We're going to calculate the module of this number, which is going to be a number from now from 0 to 9, and some 1. We're going to make it from the range of 1 to 10. If this doesn't happen, which is 9 possible cases, else reject and repeat. So the algorithm the approach we're going to use. So basically we are in an infinite while loop that we're going to check for the outcomes of this possible number from 0 to 48. We're going to calculate if the number can be mapped from 1 to 10. If it's one case when this is bigger than, for example, 41, we cannot do this mapping. So we basically repeat, go back to the while loop in the beginning. It repeats. If it doesn't happen, it goes again until it's less than this number, in which case we can calculate the number from 1 to 10, and we're going to return finally the number. Hope this is clear. And the accesses of the function, basically we will be calling the function twice, and the expected number of calls for this function. Now to answer to this question, so answering the question of what is the expected numbers of calls for the function, the Rand7, here we will have the expected number of trials that will be 1 in the probability of success. This is the expected number of calls. That in this case, it will be 1 in 40 out of 49 possible cases. This will be the expected trials that we will have, basically. This will be 49 over 40. In an approximation, 49 divided by 40 will be 225. And in a case of success, we have to call the function twice. So it will be twice multiplied this number. Basically, this will be the expected number of trials of calls for the function. Rand7. Now having these the final solutions, we are trying to submit the solution. Yeah, you have a compilation error here. Oh, I forgot to name this variable with the variable, basically. Okay, and here we have our solution. So basically, the complexity in the runtime is loading here. Okay, so we can see we have a constant axis. Basically, it's the best case that we will have in the time complexity. As it's a constant axis. In case of the memory, it's a constant axis. So here we can see our solution. Thank you so much.